Hey there everyone, Miss Hardy here. Today we're going to be learning about molarity. Right, so molarity is the way to measure the concentration of a solution. That means meaning how much of something is in our solution. So a higher concentration will have more of something in our solution, and a lower concentration will have less of something. Right, so we use an M to designate molarity. And to find that, we go molarities equals our moles of solute over 1 liter of solution. So what molarity measures is how many moles of solute, remember solute is our solid part, over 1 liter of solution. So we use our units in moles per liter. Right, also for those of you visual people, we have a nice triangle to help us remember how to calculate our molarity. There's our triangle. We have capital M, molarity is moles per liter, or for volume. So for example, what is the molarity of a solution if 3 moles of sodium chloride are dissolved in enough water to make 1 liter of solution? Okay, so our molarity equals our moles per liter. So now we have 3 moles of NaCl. Sodium chloride. And we're going to divide that by 1 liter, because that is our volume of our solution, and that is going to equal 3 molar sodium chloride. So we have 3 molar sodium chloride solution right here. There are 3 moles in 1 liter of solution. Now here comes our next problem. What if we don't have 1 liter of solution? What if we have less than a liter of solution? Well, we're going to solve that in the same exact way. Alright, here in this example problem, we have more than 1 liter of solution. So we're going to solve this the exact same way. So we are going to start out with our 0.25 moles of sodium chloride. We are going to divide that by our 2.5 liters. Alright, let's see what that equals out to. So that ends up equaling 0.1 molar sodium chloride solution. So you can see, all you do to find your molarity is take your moles and divide it by your volume. Then we end up with our molarity. Alright, let's start using our molarity triangle here to find out some other values we can do. So we have molarity equals moles per volume. Alright, so now how many moles of sodium chloride are contained in 0.5 liters of a 3 molar solution? Alright, so now we have molarity equals moles over liters. So let's plug this stuff in. We have a 3 molar solution equals our moles over 0.5 liters. Okay. Now we do all that algebra and we end up with 1.5 moles of sodium chloride. See how we did that? Also, if you cover up, we're going to use my laser pointer here. So if you cover up what you're trying to find in these triangles, so here we're trying to find moles. Okay, so we're covering up moles with that laser pointer. We're going to multiply our molarity times our volume. And that is exactly what we did here. We multiplied our molarity times our volume to find moles. Alright, now let's try a little bit more involved of a problem. I have our molarity triangle down here in the corner, so that we can use it easily. You'll be able to get that in your head pretty quickly though. So let's find this out. What mass of sodium chloride is contained in 1.6 liters of a 0.75 molar solution? Alright, well, mass isn't in our molarity here. But what is? Oh, hey, moles are a unit that can be measured in mass, right? Uh-oh. We have to convert to moles or mass from moles. Uh-oh. It's coming back. Convert to moles. All right. So to get to mass from here, let's find out how many moles we have. So remember how to find moles. We cover up what we need to find. And to find our moles, we have our molarity times our volume. All right, cool. Let's do that. So 1.6 liters times 0.75 molar sodium chloride equals, do that real quick, I believe it's 1.2. 1.2 moles of sodium chloride. Good. Now let's convert this to grams. So I'm going to tell you the molar mass is 58.44 grams per mole. So let's use this. All right, so we start out 1.2 moles over 1 times. On the bottom, 1 mole is 58.44 grams equals. So moles cancels with moles. 1.2 times 58.44 equals. So that's 70.13 grams. There we go. And now we found the mass of sodium chloride contained in that solution. All right, here's another big problem we can do. What volume in milliliters of 1.5 molar magnesium bromide solution contains 8 grams of MgBr2? I'm going to pull up the molarity triangle again here. Throw that in there. That a little bigger and put it over here. It's going to be a little bit of a problem. So what do we have to find here? All right, we have to find our volume in milliliters. Didn't tell you this, but you always have to figure this out in liters. Always convert to liters. All right, so let's see. We're going to divide our number of moles by molarity. Okay, so before we get started, we're going to find the molar mass of magnesium bromide, and that is 184.113 grams per mole. Okay, so the first thing you're going to do, okay, we see a mass. So let's convert that to moles. So let's do that real quick. 8.0 grams of MgBr2 over 1 times 1 mole is 184.113 grams. And that ends up equaling, you just second to calculate that one. So 8 divided by 184.113 equals. So we end up with 0.04 moles here. All right, now we have everything we need to find our volume. So we're going to cover up that volume there. So we have moles divided by molarity. All right, let's divide this by our molarity, which is 1.5 big M, which is going to equal probably something very small. Yes, very small. That's going to be 0.03 liters. Now let's convert this liters into milliliters here. So we're going to start with 0.03 liters over 1 times. So we're going to have milliliters on the top, liters on the bottom. So there are 1,000 milliliters in 1 liter. Multiply that together, so we end up with 30 milliliters. Fantastic. That was a hard problem, and we got through it. Excellent. All right, let's talk about how we can use this in a real-life lab situation. In labs, you're going to have to make dilutions and solutions, and dilutions of solutions. So this is actually a skill that you need. The skill of calculations actually carries over into actual lab time. So what we're trying to make here is a 0.85 molar solution of lithium fluoride, and we need 275 milliliters of the solution. So before we do anything, let's convert that to liters. So that's going to be 0.275 liters. Alright, that's good. Now, pull up our favorite triangle. And put it up in the corner here. Make sure it's nice and straight. There we go. Alright, so we have our molarity triangle. So, let's figure this out. What do we need to find a molarity? Well, you need your moles and your volume. Alright, so we have a volume and we have a molarity. So we should find the moles first. So let's figure out how many moles of lithium fluoride are going to be in this solution. Alright, so how do we do that? We're looking for moles. We're going to multiply our molarity times our volume. So we're going to take our molarity, 0.85 molar, times 0.275 liters, and find out how many moles of solute are in this solution. So we end up with 0.23 moles of lithium fluoride. Good. Alright, so how can we figure out, there's no scale in existence that can tell you this is this number of moles. That would be awesome, and it would make the lab time much easier, but alas, we don't have that. So we're going to have to convert this to grams. So the molar mass of lithium fluoride is 25.939 grams. Alright, let's figure out how many grams of lithium fluoride we need here. So we're going to start out with 223 moles over 1 times our molar mass. So 25.939 grams divided by 1 mole. So now we're going to figure out how many moles that is. So we have 0.23 times 25.939, which equals 5.97 grams of lithium fluoride. Alright, here's the fun lab part. This is what you do to make this solution. We're going to take this mass of lithium fluoride. We're going to put it in, we usually call them a volumetric flask. I'll show you these when we're in the lab sometime. They're very cool. They measure exactly a volume, so you can make perfect solutions. The only part is we don't have 275 milliliter volumetric flasks. We'll talk about that, though. They're pretty cool. And then, so you put your 5.97 grams of lithium fluoride. Let's say here's our volumetric flask. Take this, put it in here. Then there will be a little line that shows you where to fill the water up to. So you take your water and you fill it up to that line. And then you have your solution. Dissolve it in there and you have a beautiful 0.85 molar solution of lithium fluoride. So in the last problem, I mentioned that in the lab in the future you would have to make solutions and dilutions of solutions. So what exactly is a dilution? So a dilution decreases the concentration of a solute. So one of the most common dilutions is with younger children. You take their juice and you water it down. You dilute it so it's not as strong. So there's not as much sugar going on their teeth and into their system. I actually still drink my apple juice like that, but I'm strange. We know this. So before dilutions, there are more solute particles per unit volume. All right? And after the dilution, there are fewer solute particles per unit volume. So when you take that apple juice and add water to it so that it's a little less powerful, you are diluting it more, making it less concentrated. Alright, so we actually have a formula that we use to calculate our dilutions. It is one that needs to get ingrained into your mind. It is m1 times v1 equals m2 v2. Kind of remember it like a Star Wars character, m2 v2, m1 v1 and m2 v2. Sorry, that was bad. Alright, so where m1 is the molarity of the solution before dilution. Sorry, some of the words got cut off here. Volume 1, v1, is the volume before the dilution. M2 is the molarity after the dilution, and V2 is the volume after the dilution. So, I want you to think about something for a second. Think about the molarity triangle. What is your molarity times your volume? That's moles. So what we're talking about here is when you dilute something, the amount stays the same. The amount of solute in there stays the same. The volume just changes. So the thing that you have to remember here is you're solving for moles equals moles. Right, so when you put a certain number, when you put a certain amount of solution in something, you end up with a certain amount of moles. And we can find that by, calculating our M1 times our V1. And that's a certain number of moles. Now, when you take that certain number of moles and you add more water to it, the number of moles isn't going to change. Just the molarity and the volume will change. So, I'll give you an example calculation. Alright, so here's our example. So calculate the volume of concentrated hydrochloric acid, which is 16 molar. You need to make 1 liter of 1 molar solution. Alright, so we're going to use our M1 V1 equals M2 V2. So our M1 is going to be 16. We don't know V1, so that's probably what we're solving for. So M2 will be 1 molar solution times 1 molar, and then we need 1 liter. Alright, so we end up with 16V1 equals 1 mole. So we need to figure out how much of this solution do we need to have 1 mole of hydrochloric acid. So we'll do 1 divided by 16 to isolate that variable there. We end up with 0.0625 liters, otherwise known as 6.25 milliliters. Alright, so when you're making this solution, what you do is you take 6.25 milliliters of concentrated hydrochloric acid and you use enough water to make it 1 liter. And voila, you have much safer and much less dangerous dilution of acid. Alright, let's do another one of these problems. So, what volume of a 1.5 molar solution of sodium chloride would be needed to prepare 255 milliliters of a 0.35 molar solution? Alright, so again, we're going to use M1 V1 equals M2 V2. So M1 is there, 1.5 molar. Again, we don't have V1 equals M2 is there, 0.350 molar. V2, let's convert this to liters here. That is going to be 0.255 liters. Alright, let's figure this one out. So we have 1.5 V1 equals Multiply those two together, we get 0.089. So now we're going to do some more math there, so we end up with V1 equals 0.0595 liters, which is otherwise known as 59.5 milliliters, I'm sorry. Ta-da! And there's our next problem. These are very useful in the lab because we have many stock solutions, which means they're a set molarity, and from that molarity you can basically get any molarity that you need from those stock solutions. Alright, so looking at this in the lab, this same problem from the last one we did was, so we start with our calculated 59.5 milliliters of 0.15 molar solution right here. We add our solvent until we end up with that 255 milliliters of 0.35 molar solution. And this is what I was talking about with the volumetric flasks. They have a little line up here. You can see that little line right there that tells you exactly what volume you're filling to. It's very helpful. Alright, another way to calculate the concentration of a solution is by using percent concentrations. So we use three of them. We use percent by mass, percent by volume, and percent by mass volume. The last one seems a little strange, but I promise it'll make sense. Alright, so the first of the percent compositions we're going to talk about is the percent by mass. Right, so we denote percentage by mass by looking for percent W divided by W. Kind of stands for percent weight divided by weight. So what percent by mass is the mass of the solute in grams divided by the mass of the entire solution in grams, and then times that by 100 to make it a percent. So for example, if we have the mass of the solute, so if we have 100 grams solution, and so solution, that's an abbreviation for solution, and 5 of those grams are solute, we end up with, so we do 5 grams over 100 grams times 100 equals 5% weight by weight. Makes sense. Alright, so here's a real life example. So our solution here contains 5 grams of sodium chloride and 40 grams of water. So our total mass of the solution here is going to equal 45 grams. Okay, so let's do our percent mass concentration here. So we have 500 grams of sodium chloride divided by 45 grams of solution. Alright, times 100, of course, can't forget that, and that is going to equal, calculate that out, so we do 5 divided by 45 equals times 100. That is a 1.1% sodium weight by weight solution. Makes sense? We do the part here, and you divide it by the whole. Alright, now we have something that's more commonly used, and that's percent by volume. So we see that as a percent V divided by V, and that percent V divided by V equals the volume of solute in milliliters divided by the volume of solution, whole solution in milliliters times 100. So for example, when you buy alcohol products, even though all of you are way too young to do that, this is just an example, your proof is 2 times the percent volume by volume. So sometimes they'll say things like, these are 80 proof spirits, and that means they are 40% ethanol by volume. There's 40% of that solution by volume is ethanol. So if it's 100 milliliters of ethanol solution, you have 40 milliliters of ethanol and 60 milliliters of water. It's a dilution. Alright, so here's our next problem. What is the percent by volume concentration of a solution containing 150 milliliters of ethanol in 350 milliliters of solution? So our volume of our part is 150, and the volume of the entire solution is 350. So we do 150 divided by 350 milliliters times 100 equals. So we'll figure that out here. 150 divided by 350 equals times 100. That is a 42.8% volume of ethanol. Or if you want to go to the proofs, multiply that by 2 and it's 85.7 proof. Just your fun fact for the day. Alright, and now our percent by mass volumes. This one is kind of intuitive here. It sounds strange, but here it is. So represent that by percent V divided by W divided by V, or weight divided by volume. So how we measure that is our mass of solute in grams divided by our volume of the solution in milliliters. So our example here is, what is the percent mass volume concentration of a solution made by dissolving 5 grams of sodium chloride in 250 milliliters of total solution? So our mass here will be 5 grams. And our volume here will be 250 milliliters times 100. So we're going to do 5 grams divided by 250 milliliters times 100 equals. So figure that out there. So 5 divided by 250 on our calculators times 100 equals 2% WV sodium chloride solution. Alright, hopefully that makes sense to everybody. Now that we've gone through the lecture, I have a little checkpoint quiz for you. That way you can go through and make sure you understand this. And if you don't, you can either contact me through email or go back through and watch the problems over again. I do highly, highly, highly recommend doing these problems before you try the homework. It'll help you out quite a bit, and that way you'll be able to make sure that you're able to solve these problems. Alright, I hope you enjoyed my little video lecture here. I will hopefully be back next Tuesday, and I will see you all then.